Yes, you are welcome to yet another video on cation formation. In the previous video, we looked at how a lithium ion is formed, okay? And we said that the full symbol is this, and this is atomic mass, and down there we have atomic number, which is the number of protons, and the number of protons in a neutral atom is equal to the number of electrons. And the neutron number is 7, which is the atomic mass, minus 3, which is the number of protons, to have 4. Then the electron configuration from this is 2 to 1. And we said this atom is not stable, and it becomes stable by losing this 1 electron. Let's look at another example of how a cation is formed using formation of beryllium ion. Now, beryllium ion carries a positive 2 charge. The charge on a beryllium ion is positive 2. How is it formed? First of all, the full symbol of beryllium is this, capital B, lowercase e, and on the left, on the top left-hand corner, the top left-hand corner here, we have a figure representing the atomic mass, which is 9. And on the lower left-hand corner, we have atomic number, which is 4, and it is the same as the number of protons. Now, because this beryllium atom is a neutral atom, the number of protons is equal to the number of electrons, because it is a neutral atom. So the number of electrons, therefore, is also 4, since the number of protons is 4. Now, the electron configuration, the electron arrangement, is now 2 electrons in the first energy level and 2 electrons in the last energy level, to make a total of 4 electrons. Now, the neutron number, the number of neutrons, is going to be atomic mass, which is 9, minus the number of protons, which is 4. So we have 5 as the number of neutrons. I hope you have recorded down the number of protons, number of neutrons, and the number of electrons. So assuming you have recorded them down, let's try to illustrate how ions are formed, or a beryllium ion is formed. Now, we said that a beryllium ion has how many protons? We said it has 4 protons. So I'm going to pick 4 protons from this basket, and they are found in the nucleus. One of them is there, 2, 3, and lastly 4. Those are 4 protons. Then how many neutrons did we say are there? We said they are 5. There are 5 neutrons. So if there are 5 neutrons, and the neutrons are also found in the nucleus, we are going to put them there. So these are neutrons. 1, 2, 3, 4, and 5. Then how many electrons did we say are there? We said they are also 4, since the number of protons is 4. So we are putting, these are electrons. 1, 2, okay, 3, and 4. So let me space these ones, and 4. So this beryllium atom has 4 protons in the nucleus, 5 neutrons in the nucleus, and 4 electrons in energy levels. The first energy level carries 2 electrons, and the outermost, which is the second energy level, is carrying also 2 electrons. Okay, so it is a neutral atom, because the number of protons the number of protons here, 4, is equal to the number of electrons, 4. Now, let's look at the net charge on this atom. The net charge on this atom is 0 because the number of positive charges is 1, 2, 3, 4. And the number of negative charges, 1, 2, 3, 4. What is the mass number? The mass number, we said, is 9. Right? Now, supposing this beryllium atom loses some electrons, or first of all, from the electronic configuration, does this atom, beryllium atom, does it have to lose electrons to become stable or to gain electrons? Look at the outermost energy level. The outermost energy level is the second energy level in this case, and it is having only 2 electrons, so it is not stable. For it to become stable, it should either lose these 2 electrons or gain 6 electrons. But what is easier to do? To lose those 2 electrons. So let's see if this beryllium atom loses the 2 electrons, what will happen to it? So let's lose the 2 electrons. I'm picking it out. This is 1 lost, and this is the second electron lost. So we now have only 2 electrons in this beryllium atom. So we have 4 protons, 5 neutrons, but only 2 electrons. This beryllium atom is now stable. Why? Because this is the outermost shell now, which is containing electrons. Okay? So, what is the charge on this atom? Now, the net charge on this atom is now positive 2. And how is it coming in? We have 4 positive charges corresponding to the 4 protons remaining in the nucleus. So we have 1, 2, 3, 4 positive charges. But we have only 2 negative charges corresponding to the 2 electrons remaining in the energy levels. So we have 1 and 2. And so, because the number of positive charges is more than the number of negative charges by 2, the atom is now not neutral. It is now called an ion. And it is not only an ion, but a positively charged ion. So, let's look at the symbol of this ion. So, what did we say were the number of protons in the atom? We said they were 4. 3 and 4. And the number of neutrons, we said they were 5. 1, 2, 3, 4, and 5. And the number of electrons in the neutral atom, we said were 4. 1, sorry, the number of electrons, we said they were 1 and 2. Then we have 2 in the outermost shell. Okay? So we say that this atom is not stable. It should lose these 2 electrons. So we are going to lose those 2 electrons. Finally, let's look at the charge or the symbol of that atom, this atom now, after losing the 2 electrons. The symbol is capital B, small e, plus 2. This plus 2 is corresponding to the 2 electrons that were lost, or the 2 extra protons. Okay? So this is no longer a beryllium atom which is neutral, but it now has a positive 2 charge. Why is it having a positive 2? Because it lost 2 electrons, therefore it remained with 2 extra protons. So that is how cations are formed, and you can predict whether a substance is going to form a cation based on whether it is a metal or a non-metal. Thank you.